Hello pilots and welcome to a new video. Today we want to talk about the software Gyroflow. The developers just surprised us with a very big update recently on version 1.0 release candidate 1. This is a surprise in that way that the last update of the 0.3 beta was in August last year. What the developers did was they completely started from scratch and reprogrammed the whole application and created an awesome new interface for ease of use. In the past, or the early versions of Gyroflow started with Python script only that you have to control in the command line, and later with a simple Java-based user interface that was pretty sketchy and slow and very, very hard to use. But now we have a complete full-blown stabilization software or video stabilization software that can be used by everyone and is really, really fast and high performance. So first of all, what does Gyroflow do? You may already know programs like ReaSteady-Go or Insta360 Studio. These applications use the internal gyroscopes of the action cams to stabilize the video in a very clever way where you don't have to rely on image analysis, and this also works at pretty low light conditions in most cases at least. And Gyroflow brings that to a completely new level because it doesn't only support nearly every camera on the market that has a gyro inside, like Insta360s, any GoPro model starting from Hero 5, RunCam Orange, and very soon also the DJI Action Cam. It also works with cameras that don't have a gyro inside if you use the black box data of your Betaflight Quad or your Einar fixed ring, for example. So yes, you can use the gyro of your flight controller to actually stabilize the image of your HD camera afterwards. This is a really cool feature, and today I want to show you how to do that in Gyroflow, at least with GoPro footage. Currently this is a release candidate, it's not completely finished yet, so we have some issues like the Einar black box logs don't work at the moment, and I don't have a video with a corresponding black box log of a Betaflight Quad at the moment, so I can only show you the process with a GoPro at this point. First of all, what you have to do is you open the application like you see here. Here on the left side we see all the inputs the application needs. That's the video, the lens profile, and the movement data. Let me quickly switch to English here so it's easier to understand for you. So we have video information, lens profile, and motion data. Here on the top of the top center of the screen we have our real-time preview of the video. This is the big part of this application, that you can see any change you make in real time as long as your PC has enough performance. But this application is very well optimized, so that should work on most PCs out of box. Down here you have the motion graph where you can compare the gyroscope data with the optical flow image movement data that is collected later. I will show you how that works. And here on the right side you have the stabilization settings, the synchronization options, stabilization settings, the export settings, and also a few advanced settings down here. It looks very complicated on the first glance, but actually in most cases you can leave everything on default and just use the auto sync and export. But I will show you a few points where where manual adjustments might be needed. So first of all, let's load a video file. I will take this GoPro footage where I was flying with the Rafax. That's a very good example footage with not perfect conditions, but still a bit shaky, so we can see the stabilization at work. So let's turn off the sound at this point. Here on the left side now you can see the video informations. We see the file name, we see that's GoPro Hero 6 Black recording it, the resolution, duration, frame rate, the codec, pixel format and audio format. We can also add a rotation here, like if your camera is mounted upside down, for example, you can rotate the video during the process. And here we see that the video file already contains gyro data, and this is at this point very important, so we do not need an external gyro logger for GoPro cameras. Here you have your lens profile. This is needed so the camera or the software knows how the image is distorted in each area of the viewing frame. This is needed to properly detect the motion in the video. As we have a GoPro here, the GoPro writes the model and the lens settings like linear wide and ultra wide. I'm not sure right now. In the metadata, so there's no need to select the lens profile manually. For other cameras, like if you use a Runcam 2 or Runcam 2 4K or an SMO 4K, then you have to select a lens profile here. Like you can search for SMO 4K and then you select your aspect ratio and resolution, and you get the right lens profile that is needed. In this case, this is not needed for the GoPro. And down here we see the motion data are pulled from the MP4 or from the source video file directly. It detects the GoPro Hero 6 Black. That's everything is fine. And here we see the gyroscope graphs already. So the next step is we want to have a synchronization first. This is done up here with that button. You can use the auto sync to automatically synchronize the gyroscope with the video. And for that you need to set some settings sometimes, like the rough gyro offset. That's only needed if you use a black box lock. For example, if you start your recording, then you put your quad on the ground and you arm the quad like 10, 15, 20 seconds later, you have to set this time difference or this offset here, so Gyroflow knows at what point in the video the actual logging started. In this case, as we use onboard gyroscope, this is not needed because the gyroscope, the gyro logging and the video recording starts at the same time. You have the sync search size, so you can select a time span in what Gyroflow should look for matching patterns between the image movement and the gyroscope data. For any camera with integrated gyro like the GoPro, you can set that to 0.5 or even 0.2 seconds. That makes the auto sync a little bit faster. If you do it manually with a black box lock, this value should stay on the default 5 seconds. And you can set the sync points. How much or how many sync points you need depends on your camera model. You can figure that out by yourself if you leave the default. I think the default is 4 sync points or 3, I'm not sure right now. And you do the auto sync and then you check the video or you replay the video and you see some parts are perfectly stabilized, some parts are not. Then it makes sense to make more sync points. And if you use less sync points, you have a little bit less work where you have to check it, but that depends on your camera, your firmware, and so on. For example, with the Hero 6 and the 1.6 firmware version, actually 2 sync points would be totally fine. One slightly at the beginning and one at the end of the video. And for the newer firmwares like 2.1 or 2.2, don't know what the latest one is, you need more sync points because the gyro data are not written that consistent anymore with the newer firmware versions. So at this point, GoPro has messed it up a little bit. So let's start with the synchronization process. I will keep it at 6 sync points here at this point and then just click auto sync. This goes pretty fast right now. On the old beta version, this took about 2 or 3 minutes. Here you see it really rushes through the process. So after this is done, you can see down here we have our sync markers, and as you have already seen, or you might have already seen, we have only 5 markers in this case, because here at the end the marker should have been placed here, but there was no motion of the plane. If I raise that up here, you see the plane was laying on the ground only, so there was no movement. Gyroflow is only setting markers or storing markers if there is clear movement in the image visible that can be synchronized with the gyros. If there's no movement, it cannot determine how the sync pattern should be. And yeah, basically, if everything goes well and if you have a properly lit surrounding, or your image is bright enough and high contrast without any problem, then this should be enough. You have your sync points, you have your stabilization, and then we can already test how the stabilization works. So let me turn off the stabilization at this point and we just replay the video. So this is how it looks in RAW. And if I turn on the stabilization, this is how it looks like now. And you have a perfectly smooth video feed, and this is already what we want. Just to be sure that everything works well, what we do now is we just replay the video, especially around the sync points. You see these green pixels that just appeared. These are the measurement points where Gyroflow determines the movement of the image. And we just let it run and check every single sync point. So the first one was already pretty much on spot. So let's jump to the second one. Also here, perfectly smooth image, no jittering, no wobbling or whatever. Let's check the third one. This is also pretty good. It's maybe not completely perfect. Here is some slide up and down on the yaw axis, but maybe the stabilization is at this point only too low. But here you see some slight wobble, but we will look at that later. Here, this point, the fourth point, is again absolutely perfect. If we compare that with the unstabilized, it looks like this. And here we have it stabilized. So this is perfectly fine. And now let's check the last sync point here. And here we see problems. So you can see it's not really smooth. It's a little bit jittery on the roll axis. And now it gets even worse and starts to bounce around. So at this point, the sync point seems to be a little bit messed. And you already can see, as I know that that my GoPro Hero 6 has the 1.6 firmware, I know that the sync points should be very consistent. And I see a slight problem on this one here. As you can see, 26, 24 is pretty consistent. 25 is also fine. But here it seems to be a bit off. And here it seems to be completely off. And this will, like a ramp, throw off the rest of the video and gyro sync completely if this point is not right. We will look at this one first. And then now I will show you how to fix these points and how to properly adjust them. So we can check that specific point separately by clicking on it, and then we go to zoom in. So we can see the graphs very, very close here. But as you can see, there is not much movement to have some ramps here to compare. As you can see on the left side, you have the X, Y, Z axis where we can enable the gyroscope graph. And on the right side, we have X, Y, Z axis for the motion flow. That's the image analysis graphs. What we want to have is more movement, so we can properly align them. I mean, actually, it should work here on the, I think it's the Z-axis, the blue one. So you can see we have some offset. The gyro data is more to the left and the image data is more to the right at this point. So what we can try here is remove the graphs, as you can see, over here. But I'm not sure if this is enough, because still this looks good at the first glance, but here the gyro is a little bit ahead. Here the gyro is ahead. So no, I'm not happy with that. I'm not able to perfectly align it. So what we can do now is we search a part with more movement. So let's enable the graphs again. Delete the sync point. And then we check for another one. Let's just run the video a little bit further. like to where we have good amount of movement. Here maybe. So here it gets a little bit brighter. Yep, this looks good. So we can move over here. And then we set a new auto sync point here. And it will automatically detect motion again and do the same as before. So sync point is created. And now we can zoom in on that spot. And still it's not completely perfect. As you see, we also have 15 milliseconds here. And the Z-axis is still lagging behind on the image and the gyro data is a little bit faster. But now let's try to adjust that again. And if I go further here, now we can have perfectly matching curves at this point. So just eyeballing it. Now let's check the Y-axis. This also looks very good on average. And the X-axis, this also looks very good. What you can also do is if you have a little bit noisy setup, like you see these little spikes here, that means there is some vibration going into the camera or into the gyro, you can enable the low pass filter, and depending on your craft size you can raise or lower these values. Let's try a 30 Hz low pass, and voila, we have a much smoother gyro signal now we can work with. So let's check the Z-axis again, but yeah, this looks pretty much on spot to me. Okay, so we have our new sync point. This is how you create them and how you can adjust them manually. And now what we do is we zoom out of the graph here again. Then just look at this last part here again, where it was still pretty wobbly before. And if we replay now, we just let it run. These are the old synchronizing data, but they are not used as there's no sync point. And yeah, now it seems to be pretty much spot on. There's no hard jitter or wobbling anymore. And we have a perfectly smooth flight. So our sync points are done. If you are happy with that, then you can just click on export now and yeah, render the final stabilized video. But now I want to show you a few of the other settings we can do here. First of all, we can change the field of view if you want. So if you want to have a more zoomed in image, like you chase something but it's always too far away, for example, you can use the field of view and make it smaller, so you zoom in the video and it will still be the same stabilization as before. Or you can zoom out, like if you want to see the actual stabilization pattern up here. So if I now move here and you see this is our safe viewing angle. So based on the current stabilization settings, this is the part where we will go never out of frame of the original image. And this is what your viewing frame should be aligned to. So I will leave it that way right now so you can see what actually is happening. And we just put the field of view like, yeah, let's put it here. So here you can change the type of stabilization. You have a very simple pattern, that's the plane 3D stabilization. So this is basically similar to what Real Steady Go is doing. You just select a smoothness factor, and as you can see, the higher the smoothness factor is, the more the image crops in to stabilize the image or to have more headroom for stabilization. This is, by the way, this zoom in and zoom out is adjusted by this one. You can say no cropping at all. So it tries to use as much viewing angle as possible, but then you will see the out of frame parts here coming into view, even into your safe viewing area. You can say static crop. Yeah, this is pretty much useless at this point with this high smoothness factor, as it will crop the image so much that it never has to zoom, but also to always have the complete room of the maximum stabilization needed during the whole video. So if you have a very, very bumpy part and you raise the smoothness here, basically you just zoom in massively. So you have to play around a little bit with the settings. Dynamic cropping makes most sense. That's what RealSteady does by default. And it just, as you can see here, if I go like this, pretty strong stabilization level, and you see how it zooms in and out depending on how much movement we have here. Now it starts to zoom in again because now the turn starts and a little bit more wobbly. And as soon as the plane levels out, it zooms out again to have a bigger field of view. So this is completely by your liking. You can select what you want. Then we have velocity damped. This is pretty nice, as you can here set a smoothness for things like level flight, where it just goes straight and it smooths out slight input movements or wind bumps. And you can also change the smoothness at higher velocity. I can show you here at the end, for example, in this long turn. So let's start a crop here and here. So we can replay this crop over and over. And here you can see if I set the smoothness at high velocity higher, we have less stabilization in things like turns. As you can see. Or we can have a very high stabilization and very smooth turns. Or if you go into a straight flight path, let's check where we have one. Here we have very little movement. Then this one has less effect, as you can see. It's still a little bit, but not as much. But then we can have here more smoothness to have the camera view turning less, for example. You see these slight roll movements, for example, are filtered out with this slider. What I prefer is the velocity damped per axis. Here you can just use different smoothness factors for each axis. This is especially for fixed string very helpful, because some fixed strings are very sensitive on wind gusts on the pitch axis, some on the roll axis, some have issues with the yaw axis and start to wobble easily, and you can just adjust each axis individually to get the best results without too much cropping of the image. Here we have for the dynamic cropping, you have the smoothing window, so it takes a measurement over the next 4 seconds of the image and just zooms in up to 4 seconds ahead before a strong stabilization part comes, and then it zooms out if for more than 4 seconds the aircraft flies smoother already, or the camera image is smoother already. And here we have the rolling shutter correction. This is especially helpful for cameras with a rolling shutter and not a global shutter, like most cheaper action cams, or even the GoPros before Hero 8, I think. They have a rolling shutter. So if you have very strong sideways movements, to remove the image distortion, Gyroflow can do that now with the preset, and the time for the image sensor scan of 8.34 milliseconds in this case is stored in the lens profile here, or based on the camera profile, and you can use that for rolling shutter correction basically. You can try, I have no footage right now where I can really test that, but you can try yourself if you have something where it helps. It might even help for things like Jello, if you have vibrations in your video feed. Yeah, that's everything about the stabilization stuff here. And then down here we have the export settings. You can select your file format, you can select your resolution, the bit rate, and you can also enable GPU encoding. This currently only works with NVIDIA cards, and I think maybe with most Intel GPUs, but not yet with AMD. For that, a fix is coming in the next versions that also AMD GPUs are supported. And you can enable or disable the audio feed. yeah, if everything is ready, let's fix our viewpoint here, or our field of view. Let's set it back to 1. I want to have like velocity damped. So that's basically it. Now the last thing I can do is to put the crop here at this point, because we don't want to have the end after the landing. We just want to have the flight stabilized. And then you just click on export, and yeah, it's done. The video is now exporting, it's now rendering the final stabilized version. The file is stored in the same folder as the source file, just with the stabilized attached to the name. And yeah, that's basically all at the moment. I think I might make 1 or 2 more videos about that, to look into some details like the black box stuff, and try that if I can find some footage to use. But yeah, for now this should be a good overview how to use the application to stabilize your camera footage and how to use it properly. I hope you learned something today, and yeah, thanks for watching. If you liked the video, then give a thumbs up. Don't forget to subscribe to my channel, of course, and we will see us in the next one. Bye bye.